So as an engineer, you must not do fake job. That is why this part of the course is very important. You must know what you are doing. You must be responsible for things that you are doing. Are you there? So now, to determine the earth resistance test, there are standard value that we need to get. That okay, around this place, the soil resistance is this so value. If it is higher than normal standard value, then that means improvement has to be done on that soil before you go as a contractor or as the engineer that has to. Are you there? Even though people that do all the installation all around, they may not carry it out. They still believe that it will be low, and so they will carry salt, they will carry charcoal. I mean, in case if it is low, even though they will not test, but you as engineer know that it should be tested first. And this is the test we are talking about. All right. Now let me sketch the test on the board. How we carry out the test. I will sketch it on the board so that you see what we are talking about. Yes, yes, sir. So here, look at this place. Look at this place. What do we call this? What is this? Variable resistor. Alright. It's actually a real stat. The test carried out by a device that has a real stat, a variable resistor. I just want you to know whether you recognize it or not. That's what I'm asking. Recognize it, sir. Alright. So we have earth electrode like this. Right? We have soil. There is soil like this. And to show that it is soil, we hash it like this. So there is one electrode here that is called AE. AE means auxiliary electrode. Auxiliary electrode. That's far end. Where you are doing the test, you go far, do one. Okay? Now you come now. We have ammeter here. Another ammeter goes to another electrode. It's connected to ammeter to another electrode. Remember, this is soil. It means this electrode is inside the soil, isn't it? Inside the soil. So we have the earth electrode, the first earth electrode behind the house. That is EE. Earth electrode. Earth electrode. Alright? Now, we are sending current and varying the current by means of this rheostat. You know, as you vary the rheostat, current will vary. Now, it is AC supply. Take notes. This is not DC supply, it is AC that is used to the test. Okay. Now, we now have intermediate electrodes that we use to do the test as a help to the test to determine various locations. Are you there? 1, 2, 3. These are intermediate electrodes. So that means you can, when you go far, you shift it again to another place, shift it again to another place, shift it again to another place, and repeat the test. Alright, so this one, we represent this in dotted line. Sorry, dotted line. It's not always there, it's just when you are shifting that you have it. You understand that? So that one is in dotted line. So that means from here, you are carrying out the test from here to here. And then you will call the current. You take note of the supply, then you will call the current. You know, with voltage current, you can get resistance, isn't it? Yes. Then, when you finish, you move the electrode to somewhere else. So we call move to somewhere else again. You know, they will go and hammer it. How many people did COS or IT with NEPA undertaking office? And precisely the department protection, control, and metering. Who work with protection, control, and metering? When they are installing new transformers, you follow them to do this kind of test. Yes, sir. I also did. I spent 4 months. Yes, sir. NEPA undertaking office. Yes, sir. So this kind of test, they will hammer it somewhere far. They will move it again. They will say, take it to that side. Hammer it again. Then they will begin this test. All right. So this is the structure of the test. Now the earth resistance we are looking for is represented as RE, which equals the voltage drop between EE and ME. Voltage drop between EE and ME, between any of these points. This is ME, the intermediate ones. ME1, ME2, and ME, whatever. So, as you are doing it, measuring the voltage here, voltage drop between those positions and the current recorded on the ammeter, V over I, gives us the resistance of the head along that path. Are you there? Yes, sir. Very simple and straightforward. And now, after carrying it out in several positions, then you can do average of the value obtained. And the average is what we are looking for. It must be between 0.01 to 2000 ohms. That's the standard value that we should get. Anything outside here, higher than this, that means something has to be done to the soil in that place. Are you following? Yeah. That means the soil resistance is too high. The standard value is 0.01 to 2 kilo. That is 2000 ohms. Are you there now? Yes, sir. So when you have anything in that range, by standard, by IEEE standard, we believe that the soil is okay to carry current. I think you get it. Human body is a conductor. It's a conductor. Yes. So that is why the man that mistakenly holds the live camera unknowingly receives nasty ejection. Because current will force itself through his body, through that poor conductor to the ground. That is what is going to happen. So in order not to get him, not to give a fatal accident, then the earthing in the house must be standard. Must follow this process. The resistance of the soil around the building must be in the range of 0.01 to 2000 ohms. Are we together? Any question, please?